Alright, in this video I want to motivate a couple of ideas. One is, or most importantly, this idea of an infinite series, and we'll talk about that in a second, what that is. And then once we establish that definition, we'll talk about what divergence and convergence means. So let's start with this example. It says consider 16 plus 8 plus 4 plus 2 plus a half plus ... We have to write this in sigma notation. So I'm going to get my sigma sign down here. And since this looks like a geometric sequence, if you ignore the pluses, the numbers form a geometric sequence. I know that the form of that is my first term times my r value. And it looks like my r value is 16 to 8 is multiplied times a half. Multiplied times a half. So it looks like my geometric sequence rule is a sub n equals 16 times 1/2 to the n minus 1. So I know that goes here. And I know I'm doing it from n equals 1, right? I'm starting with the first term, n equals 1. And now here's the difference. Normally when we are doing geometric sequences and we were adding up the terms, we stopped after a certain number of terms. But this ... here means we're never going to stop, which means I'm adding up all infinite terms. Or in other words, I'm going to keep adding the terms like that. All right. So this, what I've just written here, this up here, the original and in sigma notation, are examples of infinite series. Okay, infinite because we're adding up an infinite number of terms, and a series just means we're adding up the terms of a sequence. So in the previous videos I could have used the term series, but I'd saved it till now. Part B says find the first 5 partial sums and the 10th partial sum. So partial sum, let me just tell you what that is. The partial sum, or the nth partial sum, simply means you're going to add up the first n terms. Add up the first n terms. So the first 5 partial sums means I'm going to start with the first partial sum. So that just means add up the first term. Well, that's easy. That's just 16. The second partial sum would mean add up the first 2 terms. 16 plus 8 is 24. The third partial sum is 16 plus 8 plus 4, which equals 28. The fourth partial sum would be add up the first 4 terms. So I'm not going to write out 16 plus 8 plus 4. I know that I'm going to have to add up 16 plus 8 plus 4 plus that 2. So I'm just going to add the 2 to the previous result to get 30. And my fifth partial sum, I'm just going to add up the first 5 terms, and that's just adding a half to this 30, really, when you think about it. So there are the first 5 partial sums. And then it says to compute the 10th partial sum. So the 10th, I'm going to add up the first 10 terms. And here I'm going to appeal to the formula we already know. This is a geometric sequence, the terms. And so I'm going to use my formula. My formula says that to add up the first 10 terms, I take my first term, multiply it times 1 minus my r to the 10th, and then divide that by 1 minus my r. And this ends up being 16. So if we put this in the calculator, we get 16 times 1 minus 1/2 to the 10th. So it's 15.98435. And then I'm dividing that times 1 minus 1/2, which is 1/2. Divide that by 0.5, and you get 31.36 875. So there's the 10th partial sum. Okay, so let's look on the next slide for another example. Alright, it says for each of the following series, we only have one here, but there's two in the next page. Find the first 5 terms in the sequence of partial sums. So I'm doing a few examples for a particular reason, which you'll see in a few minutes. But the first partial sum is just, as usual, the first term. The second partial sum would be 0.1 plus 0.01, but that's just that's just 0.11. The third partial sum is 0.111, right? Because it's 0.1 plus 0.01 plus 0.001. The fourth would be, I think at this point you have a sense what's going on, right? I mean, the 10th would just be 0.1 with 10 ones, right? So I'm going to put something down here. I'm going to just list what the partial sums are as a list, right? So the first partial sum was 0.1, and then we had 0.11 and 0.111. Etc. Clean that up again. Alright, so there's my list of partial sums. I want you to try the next two on the next page. You go ahead and try. Do exactly what I did here on your own. Try these on your own.